Okay, we continue with buffers for proximity analysis. So a buffer is a polygon surrounding map features of a feature class. So as the analyst, we will specify buffer's radius, and then the buffer tool will sweep the radius around each feature, remaining perpendicular to features. To create buffers for points, buffers are circles. For lines, they are rectangles with rounded endpoints. And for polygons, they are enlarged polygons with rounded vertices. So generally, we will use buffers to find what is near approximate to the features being buffered. For schools symbolized as points, 1,000 foot school buffers define drug-free zones. Any person convicted of dealing illicit drugs within such zones will receive a mandatory increase in jail sentence, which is intended to serve as a deterrence to selling drugs to children. We will analyze drug-free zones here. Another example of spatial analysis with buffers is food deserts, which are often defined as areas that are more than a mile from the nearest grocery store in a city. Often the person living in food deserts are poor and from minority populations, and it's straightforward to analyze affected populations using selection by location. We will select the populations within buffers and then analyze selected features, for example, using ArcGISPro ability to summarize data. Additionally, from the book source webpage, we will have the opportunity to explore the topic later, and later we will do an analogous problem to food deserts of urgent healthcare deserts in Pittsburgh, areas more than a mile from the nearest urgent healthcare facilities. And then last assignment we will do for food deserts, finding the best locations for additional farmers markets in Washington, D.C. Sometimes buffers are exactly the right tool. One such example are the drug-free zones, for which federal and state laws prescribe a buffer radius, generally 1,000 feet of school properties. Other times, buffers are less accurate but provide a quick estimate. One such case is geographic access by youth to public swimming pools in Pittsburgh, because users of the pools travel the street network to get to the pools. Pittsburgh has an irregular street network because of its rivers and hilly terrain. So even though some youth appear to be choose to a pool on a map, they may have no direct route to the pool. In this case, we will need a network model that uses travel distance on a street network data set. Buffers estimated with street networks are called service areas, and we will work with them in a later part for the public swimming pools in Pittsburgh. And now, so we have some buffers here, and we will the street networks we will we will not go over now until when we're done with every exercises, and then we will summarize this, okay? And the first one in here, the buffer Pittsburgh school will find illicit drug dealing arrests within drug-free school zones, 1,000 food buffers of school. And the drug arrests often occur at the scene of drug dealing, so arrest location, which are the same as illegal drug sales violations, are relevant for the analysis of here. And now first we will use the north side bookmark Pittsburgh and any city. Pittsburgh north side has so many schools that it sees most drug arrests, as seen here in north side Pittsburgh, and we will likely fall into drug-free zones. And here, a person's names in the drug violation feature class are often from random name generator and are not actual names of arrested persons. Also, dates, exact addresses, and other data have been changed to protect privacy. And we will run the buffer tool on the analysis toolbar. We will click Tools. So analysis, we will go to Tools, and then we will say Buffer. Okay, and type or make the selection here. So the No Dissolve option creates a separate buffer for each point feature. The opposite dissolve dissolves interior line of overlapping buffers, merging them into a single buffer. A dissolve buffer gives you the distance to the nearest facility, school in this case. So input feature here, of course, we will do is schools. And output feature class, we will say schools buffer, that's fine. Distance value, linear unit, and we will say 1,000 feet. And the method will be planner and dissolve, no dissolve. And we will run the buffer tool and use it after it finishes. And take the color fill out of the buffer. We will move the drug violation above school in contents pane and turn off the school labels. So I think I will keep the labels. That I will do is close this out and go to properties, and I will say no color there, and we will use blue, and I will make it 2. Click apply. Okay, so we are looking at the map along, and we cannot readily determine whether drug-free zones deter drug dealing near school in Pittsburgh. So we will analyze the issue in here. Note the overlapping buffer in the figure. The buffers were made instead with the dissolve option. Each set of overlapping buffers will be placed with a single buffer consisting of the outline of each set. And now we select drug violations with drug-free zones on the map tab here. We will click the select group layer. So I'll close this out map, and we will select by location. So for select by location, we are doing is drug violation within drug-free zones. All right, we will do the input layer. We will select drug violation. For selecting feature, we will do relationship school buffer relationship. We will say that selecting this relationship, it didn't say about relationship, and open the drug violation table and see how many violation are selected. So and intersect, that's fine, intersect. All right, let's see how many schools are selected. School buffer, geoprocessing, select by location. Okay, select violation by location. Okay, we did this input feature, and for output feature, okay, open the drug violation table. Let's see there, and we will go. Okay, 222 are selected out of 651 violations here. So it's around 33.8% of all drug violations, and we will close the table and clear selection. Clear everything. And now we will move to next step, which will be if the drug violation occurred randomly in Pittsburgh, then for any given area within Pittsburgh, we will expect the fraction of such crime to be the same as the area's fraction of Pittsburgh area, we will run the buffer tool again with school as input, school buffer dissolve as output, 100-foot radius, and this time with the option to solve all output features in a single feature. Then divide the area of the resulting buffer by the area of Pittsburgh. So the areas are in square feet, so are large numbers. We can copy and paste them into Microsoft Excel from shape area attributes to the of the two features classes to do the division. We will get the number, but and then alright, so we will do it one at a time. Okay, so this might take some time. Alright, so we will back on analysis, tools, buffers, and input features. Input features that I will have as buffer to school as inputs, and buffer, okay, with a dissolve, with a D. So the same, we will do linear unit and 1,000 feet, okay, and dissolve, okay, option, we will say dissolve all output feature into a single feature. Click run. And then once we have the buffer that we get dissolved, and that we then divide the area of the resulting buffer by the Pittsburgh. Both areas are in square feet, so there are large numbers. So we copy them into Microsoft Word and do the division. We should get so do the division. So let's look at those large numbers. So we will have not drag violations, it's this one, open attribute table. Okay, this is the area. I think we don't have to, so I can just create a field. Alright, so I would say here, I'll just say percent data type. It could be, yeah, it will be float. Okay, float. And that's it. So I'm gonna save it and back to the field calculator. And here I will say calculate field. That percent equals to 39, this area. Okay. Shape area, and we will divide. The number is 16270999663. Okay, and then click run. Oopsies, I didn't have my number lock. 16270999663. There. So click run again. It doesn't show up. Alright. 16270999663. There, I will run it again. There, yeah, 0.25%. But earlier we found that it's a substantially higher fraction. 33.8% of drug violations occurred in drug-free zones. Although not a definitive result, we should be suspicious that drug-free zones are not working in Pittsburgh. A better estimate, however, than the one we just did use the Pittsburgh area with human activity instead of all Pittsburgh for the divisor. We have to subtract the area of rivers, cemeteries, steep hills, and so on, which Pittsburgh is about 50% of its area. So we would expect 49% of drug arrests to be in the drug-free zones buffers, which is considerably larger than the 33.8% found. So perhaps the law reduces drug dealing near